Welcome back to Chem Sleeping Lab, Episode 7. Last time we talked about acids and bases. Tonight we will talk about solvent, the liquid that dissolve other things. In episode 1, we talked about pure substances and mixtures. A solution is a type of mixture, a very even mixture. In a solution, there are two parts. The solute is the thing that gets dissolved. It can be a solid, liquid, or gas, like salt or sugar. The solvent is the thing that does the dissolving. Usually, there's more of it, like water. So, salt water is a solution. Salt is the solute. Water is the solvent. In daily life, water is the most common solvent. We call it the universal solvent because it dissolves many things, but not everything. Coffee is a solution. Water is the solvent. Caffeine and many flavor molecules are the solids. Air is also a solution, but of gases. Nitrogen is the solvent because there's most of it. Oxygen and others are solids. In the lab and in painting, cleaning, and factory work, we often use other solvents, not water. We call them organic solvents. Organic means their main structure contains carbon and hydrogen. Common examples you might have seen: ethanol, alcohol, and hand sanitizer. Acetone in nail polish remover. Isopropyl, rubbing alcohol. Hexane, heptane, sometimes in glues. Toluene and xylene in pens. Why do we use them? Because water cannot dissolve everything. Oil, grease, some paints, many plastics. They do not dissolve in water, but they do dissolve in organic solvents. That brings us to the famous question: why does oil and water not mix? Because of how their particles attract each other. We call it Polarity. Water is polar. Its molecule has a slightly positive side and a slightly negative side, like a small magnet. This is because oxygen pulls electrons a little more than hydrogen. So water molecules like to stick to other polar molecules, and they form hydrogen bonds, a relatively strong attraction. Oil, like vegetable oil or hexane, is nonpolar. Its electrons are shared quite evenly. It does not have strong positive and negative sides. In chemistry, there is a simple rule. Like dissolves like. Polar likes polar. Nonpolar likes nonpolar. Soap is interesting because it has both. One end is polar, likes water. The other end is nonpolar, likes oil. So soap can bring oil into water as tiny droplets. That is how soap cleans. So when SDS says water soluble or insoluble or soluble in organic solvents, it is telling you about polarity. This helps you choose how to clean a spill and what PPE might work. Most organic solvents share two hazards at the same time. That is why they need extra care. Hazard 1. Flammability. Many organic solvents are volatile. Volatile means they evaporate easily at room temperature because their intermolecular forces are relatively weak compared to water. When they evaporate, they make flammable vapor. We talked about flashpoint in episode 3. Most organic solvents have low flashpoints. That means at normal room temperature, they always give off enough vapor to burn if there is an ignition source. And many solvent vapors are heavier than air. Acetone vapor is heavier than air. Toluene vapor is heavier than air. So they can sink, flow along the table to a faraway spark and flash back. Hazard 2. Health effects. Route 1 is inhalation. Because they are volatile, you can breathe them easily. Small amount may cause headache, dizziness, feeling sleepy, or irritation of nose and throat. Road 2 is skin. Many organic solvents can remove the natural oils from your skin. Your skin may become dry, cracked, and more often to other chemicals. Route 3 is chronic. Breathing low levels every day for years can affect liver, kidneys, or nerves, depending on the solvent. That is why one liquid can have two GHS pictograms, a flame for flammable and an exclamation mark or health hazard silhouette for toxicity. How do we handle them calmly and safely? Risk equals hazard times exposure. Here, hazard is both flammable and toxic, so we must control exposure in two ways at once. 1. Ventilation first. This controls both fire hazard and health hazard at the same time because it removes vapor. 2. Keep away from ignition. No open flame, no hot plate, no sparking equipment nearby, and be careful about static electricity. 3. Use small amounts. Do not keep a big open beaker of solvent on a bench. Take what you need and close the bottle. 4. Store correctly. Keep them away from oxidizers like concentrated peroxides and nitric acid. 5. PPE is last line. And if there's a spill, ventilate. Remove ignition sources. Contain with absorbent. And clean up with non-sparking tools. For small spill in lab, tell someone. Open fume hood and follow SDS Section 6. Accidental release measures. For large spill, leave and call for help. A small calm habit. always read SDS Section 2, Hazards, Section 5, Firefighting, Section 7, Handling and Storage, and Section 8, Exposure Controls, before using a new solvent. Let us review for today. A solution has solid and solvent. Many organic solvents are nonpolar, good at dissolving oil and grease, but they are volatile with low flash points, so flammable, and their vapor is often heavier than air. How we handle them. Ventilation first. Keep away from ignition. Use small amounts. Store away from oxidizers and use PPE. That is all for episode 7.